Good morning, neighbors. I want to talk about quantums. Quantum, Quantum, the word, what it is, what it means. This one, quantum, is like the word evolution. Evolution can have a broad thing. I speak to the evolution of electronics and the measurement sciences and applied systems and computer systems and automobiles, maybe welding techniques, automated guided vehicle systems, things like that. So, quantum. Let's get back to a quantum. Quantum in its simplest word, simplest form, is just a sum of things. A quantum could also be called a cohort, but you really wouldn't want to do that. A cohort has another specific definition of what it is, but in a way it's a sum of interesting events, so you could term it a quantum, right, depending on how you want to use this word. So the room you're in, this changes. When you go into precision measurement, we use this word quantum in a pretty specific way. There's not much woo attached to it. We understand that we're getting a sum of some type of things in a measurement. Now, it's truly odd. Most of the measurement instruments that you work with could be called quantum measurement machines. They're measuring the sums of electrons, let's say, in something. This is what my optical emission spectrometers did. They had a summing capacitor off of the high voltage line feeding the tube, and that little summing capacitor added up individual electrons into a measurable voltage. So the interrelationship formed a quantum. These hard definitions begin to matter very much in the measurement sciences. Now, where the amazement in this quantum word comes is when you get into measurement of electrons. In this word photon, we call it a photon. The only way we can measure photons is in quantums. There has to be enough of them for us to detect. It's very hard to detect one of something. It's an interesting fact. So we know these quantums, this word is useful out there in the sciences, but you have to have the framework around the word for the room that you're standing in, talking about a quantum sum. So what does this word have to do with electron movements, with the sun? Well, now we get into photons and electrons and their interaction. We measure photons in quantums. I'm used to very large quantums, very large cohorts, very large samples. Some people can do very finite sampling. They can actually see electron orbitals now in their little lab off in a corner somewhere. If you spoke to that person, it's staring into that, whatever it is, electron microscope. He might be using that word in his mind just to summarize all the blue dots on a slide he's looking at. Until he knows better what they are, he's got a sum of blue dots. And he's seeing them because of photons emitted by the objects somehow. And the photons are caused by movements of electrons. Once that electron moves, the physics of it is actually collapsing down one shell. The energy required to move down one shell in that Bohr's model is released as what we term a photon of energy. That photon travels between every electron in its path. And it travels as a wave, which makes it even more confusing. So now we've got wave theory thrown in here and how waves travel. Ocean waves, ripples on a pond, are a simple mode of that. It's energy that's moving, making the wave, and the water doesn't care. It doesn't change the water, it moves the water. So this photon electron line, the interaction with electrons is the only way we see that photon energy. A photon has no mass, yet it's a traveling energy wave. None of this makes it a lot easier, but the concept of a quantum is very important in these measurement physics. These sums of things we think we know. And that's only talking about an electron and its energy mechanism, which is photons. That's part of its transport mechanism, how that electron moves. So we know now we can hit electrons in any of Bohr's model shells with very specific photon energy, specific frequency of photons, selects the electron shell inside specific atoms, just specific atoms. Now what happened here? I just went into frequency interactions, because frequency is the expression of energy in a photon. But now I opened up the woo factors of frequencies and crystals and harmonics and shaving cream. So it just got more complicated, and you have to be able to sit back and try to context the speaker, I would guess, to understand what they're saying. Not fight it, not argue with it, just simply understanding what they're saying. And maybe 10 years later, some of those pieces will come together. I don't know. I'm just not sure. And I'm confident I can say that. I'm going to do one about buckyballs next. How exciting is that? Not buckyballs. Plutonium pits. Yay! They are related to buckyballs, you know that, but it crossed my mind and came out. Too long a video. Good morning.